This is the second video on Chapter 23, Systems of Linear Equations. We're going to do example 277, which has two parts, A and B. Both of these are homogeneous systems. What that means is the constants on the right of the equal signs are all zero. So that's the same for part A as part B. So we start with our system of linear equations, and we write the coefficient matrix. We don't need to bother with the augmented matrix because the fourth column would just be all zeros, and those would not change with row operations. So essentially what we're doing when we're solving a homogeneous system is we're looking for the null space of the coefficient matrix. So we take our coefficient matrix, we put it in reduced row echelon form, and we have this matrix here. And so now remember, because these two matrices are row equivalent, they have the same null space. And so we'll find the null space of this matrix right here. We see that we have a free column. Our third column is a free column. The first two columns are pivot columns. So we have a free variable. Our free variable is z. It's the variable represented by the free column. So our free variable is z. Remember how we find the null space of this matrix. The thing about a free variable is we can let it be whatever we want. So to find a vector in the null space, we'll set z equal to 1. And then we go up the column and we change the signs. So we have a -1 in the second position and a +2 in the first position. So this vector is in the null space of this matrix. Remember, the null space is actually a subspace of R3. And so we take the span of this vector is the entire null space. So every multiple of this vector is a solution, represents a solution to this system. So this is a system with infinitely many solutions. I'm going to say this again and again and again. Every system of linear equations has 0, 1, or infinitely many solutions. This one has infinitely many because it's the span of this vector. For part B, we do a similar thing. We start with our system. We write the coefficient matrix. Again, there's no need to make the augmented matrix because the fourth column would simply be 0 and would stay zeros all the way through whatever row operations we have to perform to produce the reduced row echelon form of this matrix. So we take this matrix, we put it in reduced row echelon form, we have the identity matrix. Remember, the null space of any identity matrix is only the 0 vector. I wrote I3 here because we're in R3. So the null space is the 0 vector, so the only solution to this system is the 0 vector. Again, a system of linear equations has 0, 1, or infinitely many solutions. I will say a homogeneous system always has at least one solution. Anytime you have any homogeneous system, the 0 vector is always a solution. Sometimes it's the only solution, sometimes it's not. But when you have a homogeneous system, you always have either one solution or infinitely many solutions. It's never the case that a homogeneous system has no solution, because the 0 vector itself is always a solution.